So far, we've been talking about rational expressions. The last thing we're going to talk about are rational equations. What are rational equations? Well, they're rational, or they're expressions that equal each other, where at least one of the expressions is a rational one. Right? So a rational equation an equation that has at least one rational expression in it. And you got to understand the difference between rational expressions and rational equations. Okay? Like for example, if I wrote this, x over 7, I have just written a rational expression. If I make it equal to 5, I have now written a rational equation. See the difference between the two, right? Let's say, for example, another one. 2 over x squared plus 2x. I just wrote a rational expression. As soon as I make it equal to something, it changes to a rational equation. So I could have 1 over x plus 2. Those are examples, right? With rational expressions, all we do is we simplify them, we add them together, subtract them, multiply them, divide them. We never find out what x is. We just put it into a simpler form, okay? The only time you would ever do anything with a rational expression is if I told you what the variable was. However, a rational equation, as soon as it equals something, now we're trying to figure out what x is. Now we're solving. Okay, we simplify rational expressions. We solve rational equations. So to solve these things, first thing, make sure all denominators are factored. That's the first thing. Once you've got them all in factored form, you must state non-permissible values. And there's a reason for that that you'll see. Or we also call them restrictions. Now remember, when we solve equations, we're trying to get x by itself on one side and whatever the value is, the solution is, on the other. So we want to get rid of the fractions. We want to clear the fractions out. So we have to multiply every term in the equation by the LCD, lowest common denominator, to clear the fractions. We don't like fractions when we solve equations. We want to get rid of them. Once you get rid of them, you've got sort of a regular looking equation, and you guys know how to solve those. Solve and check your solution, or there may be more than one solution, we'll see. Are not non-permissible values. That's something you got to be careful of. Because if you solve and you get an answer that's a non-permissible value, well, you can't have that answer. Solve and check your solution is our non-permissible values. What's the problem? You'll see in a second. Well, then that's good. Okay. We simplify rational expressions. Okay. When we work on rational expressions, our answers are going to be likely fractions, like we've been doing. Okay. Answers will likely be fractions. Sometimes they simplify all the way to a non-fraction, but for the most part, they are fractions. But we solve rational equations. There will be no fractions left. We want to get rid of them to figure out, help us figure out what the value of x is, or whatever the variable is. Right? Okay, so let's look at a few. So in A, we are solving for A. We've got, it's a rational equation. How can you tell it has a rational equation? Well, it's got an equal sign sort of in the middle of it. Okay. Like this would be a rational expression. I'd ask you to add those together and your answer would be a fraction. This is a rational equation. We got to get rid of the fractions and figure out what A is. But before we do that, we have to state the non-permissible values or the restrictions. What can't A be? 0. Any other numbers? Or just 0? Just 0. Now, we got to multiply by the LCD to clear out the fractions. So we got to figure out what the LCD is. A, 2, and 5A. What is the smallest expression all three of those go into? 10A. Because the lowest common denominator of 2 and 5 is 10. And because we have some A's here, there has to be an A in the LCD as well. Now, we're going to multiply every term by 10A to get rid of the fractions. And remember, 10A is the same as 10A over 1. So we can do some canceling. We can do some reducing. The 10a will get rid of all the denominators. What's 10a over a? What's an easier way to say that? 10a divide a. 10. What's 10a divide 2? 5a. What's 10a divide 5a? 2. Just 2. Notice all the denominators are gone. So we are left with 10 times 4, which is 40, equals 5a times 1, which is 5a, plus 2 times 3, which is 6. Just a regular looking equation. Get a by itself. So move the 6 over to the other side, and we get 34 equals 5a. Divide both sides by a, and we get 34 divided by 5. Is that a restriction? Is that a non-permissible value? No, the non-permissible value was 0. This is okay. If we solved this and it worked out to 0, we can't accept it. There would be no solution. You would just write no solution. Okay? Remember, when there's more than one term, you got to think of them together with parentheses. What can't x be here? 2 and 1. And what's the LCD of x minus 2 and x minus 1? You just multiply them together. So that means you've got to multiply every term in the equation by this. So we've got to take x minus 2 times x minus 1 times this fraction. Equals LCD times the second fraction. And when we do that, we'll see we can cancel out, we can get rid of the denominators. What cancels out here? Yeah, the x minus 2. So what am I left with? I'm left with 5 times x minus 1. What cancels out here? The x minus 1. So I'm left with 4 times x minus 2. And remember, when we multiply a binomial by a number, we always put the number first. Okay, so we've got to get rid of the parentheses by multiplying through. 5x minus 5 equals 4x minus 8. Take the 4x over to the other side by subtraction, and I get x minus 5 is equal to negative 8. Add 5 to both sides, and I get x equals negative 3. Is that a non-permissible value? No, so it's good. You will come across one where it is. We will get there. Okay? Next one. Okay, I see binomials here and here, so I'm just going to remind myself to group them. Restrictions or non-permissible values, x cannot be 1. What's the LCD? Sorry? X minus 1, right? The LCD is x minus 1. Well, that's not terribly So I got to do x minus 1 times 7x over x minus 1 equals x minus 1 times 5. Remember, you got to multiply everything, even the non-fractions. Plus x minus 1 times 7x over x minus 1. So the x minus 1's go in both of them. So I am left with 7x on the left side. What is x minus 1 times 5, or 5 times x minus 1? 5x minus 5, and then I've got another plus 7x. So I can simplify the right-hand side a little bit. 5x and 7x make 12x. No, I want to take the x's over, right? I can leave this here. I want to get the x's together. So I got to subtract 12x, and I get negative 5x equals 5. Yeah, you could have done the plus 5 and the minus 7. That still would have given you the answer. Sorry, that's negative 5. Therefore, x is 1. Right. If you look up top, x cannot be 1 because it's an NPV. So that means there is no answer. Or in other words, there is no solution. Always check. I'm actually going to skip D for now and move on to E. We're going to go back and do D, just not yet. All right, this one, we got to do some work to it. Remember, everything has to be factored. Before, everything was already factored. I didn't have to worry about it, or I couldn't factor them. But this one, there's one I can factor. Yeah, x squared minus 4 factors to what? X plus 2, x minus 2. Equals 2 over x plus 2 plus 1 over x minus 2. What are the restrictions? What can't x be? 2 and negative 2. What is the LCD? You don't have to write the LCD all the time. I just write it. Yeah, I need an x plus 2 in it because there's x plus 2 appears a couple times in the denominators. And I also need an x minus 2 in it. But nothing else appears in the denominator, so that's all I need for the LCD. So this is going to look like a fairly big step because you've got to take the LCD, x plus 2, x minus 2, and you got to multiply by everything. See how some of these can get a little lengthy. Once this step is done, though, it gets much more efficient after this. So what cancels here? Both of them, so I'm left with 1. X plus 2's cancel, so I'm left with 2 times x minus 2, or if you want to multiply it through, you can, sure. And then the x minus 2's cancel, and I'm left with plus 1 times x plus 2, which is just x plus 2. So I get 2x minus 4 plus x plus 2. I can simplify the right-hand side. I get 3x minus 2. Well, I've already got 1x by itself on the right-hand side, so I'm just going to move this over here. So that becomes 3 is equal to 3x. Divide both sides by 3, and x is equal to 1. Good? Yeah, it's good. It's not one of the restrictions. Okay. So I'm going to stop there, and we're going to do the remaining 3 on Wednesday, because all of these, when we got rid of the fractions, the equations that were left were pretty easy to solve. Just get x by itself by moving things from left to right, etc. Get our answer. But remember, we learned how to solve a new type of equation this year, the ones that have the x squareds in them. So what happens when you cancel everything out and you're left with a quadratic? Well, you got to solve it like a quadratic, which means usually factoring. But we'll talk about that next time. So in the meantime,